Hi everyone, this is Professor Oaks, and in this video we're going to talk about solving systems of equations by graphing here. So, you can see in this first problem here, it says find the solution to the linear system, and that means a linear system of equations depicted in the line below, and it's linear because these are both lines here. And so the solution to a linear system of equations will be the point where these intersect, and you can see the point where these two lines, this one and this one, intersect is actually at 6, 3. So that is the solution. 6, 3 is the solution to this linear system of equations. All right, so let's try another one. Find the solution to the linear system depicted in the following graph. Again, that is the point where the two lines here in the system of equations intersect, and this point you can see is 1, -3. So now here is another question here. Solve the system of equations below by graphing here. So I have a piece of graph paper here, and I'm going to write the problem down on this piece of graph paper here, the system of equations that was given here, and we see it was 3x minus y equals 5, and 5x plus 4y equals -3. To solve the system of equations by graphing, and I'll even get out my ruler here, we will start by graphing each of these lines here. All right, so we have 3x minus y equals 5, and if we think about it, there are lots of ways that we can do this, and one of these ways would be to substitute numbers for x and figure out what the y value is. So x, all right, so let's try this here. All right, so if x were, let's say it was 0. All right, so then we have 3 times 0 minus y is 5, negative y is 5, so y is -5. So one of the points is 0, -5. So 0, -1, -2, -3, -4, -5. All right, let's try a 1 here. So 3 times 1 minus y is 5. 3 minus y is 5. Subtract the 3, so the opposite of y is equal to 2, and y is -2. All right, so 1, -2. So 1, 2, 3, 4, 5. 1, -2. So now we could do one more point if we would like, or I can just carefully draw the line. And when I say carefully, please make sure that you are as careful with drawing this line as possible, which is also why I broke out the ruler here to make sure that I am doing this as accurately as possible here. So if I do this, all right, line this up as accurately as possible to go through these 2 points. And here is my first line. Now, let's look at the next line here. We have 5x plus 4y is -3, and I can pick values for x and substitute them in again. So let's say I pick 0 again. So 5 times 0 plus 4y is negative 3. 4y is negative 3. And y is negative 3 over 4. Well, let's say I know that that is one of the points, 0, negative 3 over 4, but I don't necessarily want to, say, have fractions. Then I could pick a different point until I don't get any fractions, right? So let's say I pick 1, all right? So 5 times 1 plus 4 times y is negative 3. 5 plus 4y is negative 3. Subtract the 5 to get 4y is negative 8. And divide by 4 to get y is negative 2. So 1, negative 2. And you can see that that is already the point that these two lines intersect at, because it is a point on both lines. But let's say I pick one more point just to be absolutely sure. And let's see, what else could you pick here? Let's say that you pick a negative 3. So x could be, say, negative 3, and then you have 5 times negative 3 plus 4y is equal to negative 3. So negative 15 plus 4y is negative 3. Add the 15 to get 4y is 12, and then divide by 4 to get 3. So you have negative 3, 3 is another point on the graph. All right, so negative 3, 3, and here would be 0, negative, whoop, you can't see that, negative 3, 3, and then you have the 0 and negative 3/4 right about here, and then the 1, negative 2, and then you carefully draw this line as best as you can here. All right, and again, you're just looking for the the intersection point, which I already found here, and the intersection point is going to be 1, negative 2. So this is the solution to this system of equations. Now, remember, if the question is asking for only x, then x would be equal to 1. And if the question is asking for y, then y would be equal to negative 2. All right, so let's do another example of one of these systems of equations. So here we go, solve by graphing here. And we have, here is one here. 4x minus 3y is equal to 1. Negative x plus 5y is equal to negative 13. And now let's draw our coordinate system here. All right, so we'll again graph both of the lines and see where they intersect. So we have, first of all, the 4x minus 3y equals 1. And we can substitute numbers for x, so say 0. So 4 times 0 minus 3y equals 1. Negative 3y is equal to 1. So y is negative 1/3. So there is one point that we could graph, but it's a fraction. So you might want to think of some numbers here that you could use that won't give you fractions. All right, so let's say that you use 1 here, so 4 times 1 minus 3y is equal to 1. 4 minus 3y is equal to 1. Subtract the 4, so negative 3y is negative 3. And divide by negative 3, so y is 1. So another point is 1, 1. All right, now again, you can pick any x value, so I'm going to pick, say, 4, and 4 times 4 minus 3y is 1. 16 minus 3y is 1. Subtract the 16, so negative 3y is negative 15. Divide by negative 3, so y is 5. So we have a point at 4, 5. So here we go. We have I'll just graph the whole number that we got here, the 1 and the 5. So 1, 1, and 4, 5. So 4, 5. All right, so here is the line, and just try to, again, draw it as accurately as you can. Yeah, so as accurately as you can. So if I'm as accurate as I can, I just want to make sure that I line these up and I don't make any mistakes here. All right, so here is the line as accurately as I can given my graph paper that I have here. So now let me go ahead and graph this next line here. So we have negative x plus 5y is negative 13. So we can pick values for x to substitute in here. So let's say we have 0. So negative 0 plus 5y is negative 13. And then we have 5y is negative 13. And y is negative 13 over 5. Again, I probably want to have numbers that are not fractions. So let's go with let's go with 3. So negative 3 plus 5y is negative 13. I'll add the 3 to get 5y is negative 10. So y is negative 2. Right, so that is a good choice here. And let's go with, say, negative 2. So the negative 2 plus 5y is negative 13. So 2 plus 5y is negative 13. Subtract the 2, so 5y is negative 15. Divide by 5, so y is negative 3. So our points that I have here are 0, negative 13 over 5, and 3, negative 2, and negative 2, negative 3. All right, so let's graph the 3 and the 3 and the negative 2 and the, let's see, what do we have? In the negative 2, negative 3, and the 0, negative 13 over 5. So that's, well, that's right in the right in there in between these. But right now I am just going to go ahead and draw the line between these two points. All right, so if I do this again as carefully as I can so that I make sure that I can clearly tell the intersection point of the two lines, because that will be the solution to the system of equations, we can see it happens to be at -2, -3. So that is the solution. Now, if the problem asked for only x, then we would give -2. And if it asked for y, we would give -3. Otherwise, the solution is -2, -3. All right, let's try another one here. All right, so there, let's do one more here by graphing. So here's another great example of solving a system of equations by graphing here. So here is one of these. It is 5x minus 2y is equal to 21, and -10x plus 4y is equal to -42. All right, so let's see here. So now let's go ahead and graph each of these, but I'm going to set up my coordinate system here. All right, so here we go. All right, here we go. All right, so 5x minus 2y is equal to 21. X, y, let's pick some values for x. So let's say 0 again. 5 times 0 minus 2y is 21. -2y is equal to 21. Y is 21 over -2. All right, so now let's see, if you pick, even if you pick, say, a 1, you have 5 times 1 minus 2y equals 21. Subtract the 5, -2y is equal to 16. Divide by -2, y is -8. And then let's say we pick a 3. 5 times 3 minus 2y is 21. 5 times 3, 15 minus 2y is 21. Subtract 15, so we get -2y is equal to 6, and then divide by -2, so y is -3. So we have a point at 0, -21 over 2, 1, -8, and 3, -3. So let's see, we have 1, -8, -1, -2, -3, -4, -5, -6, -7, -8, and we have 1, 2, 3, 4, 5, 6, however many you want. So we have 1, -8, and 3, -3, and then you can go ahead and see what this is going to look like. All right, so try again to make this as accurate as you can. All right, so it's really, again, I want you to be as accurate as you can, but like if you're a little bit off, that's fine, but try to make sure your graph looks like it goes in the DIA every day of the week. All right, so this graph needs to look as nice as it possibly can. So now, here we go. Let's graph the second line here. -10x plus 4y is -42. So x and then y, so 0, and negative 10 times 0 plus 4y is negative 42. So 4y is negative 42, or y is negative 42 over 2. And that reduces to negative 21 over 4. Whoop. And that reduces to negative 21 over 2. All right, now you see that this point was on both of the lines. All right, so let's pick another one. 1. So we have negative 10 times 1 plus 4y is negative 42. Then add the 10, so 4y is negative 32. And divide by 4, so y is negative 8. So we have the point 1, negative 8. Well, that point was on the other line as well. So what this means is that these are exactly the same line. If you kept on going, you would see, even if you, let's say you pick the 3 over here, you would have negative 10 times 3 plus 4y is negative 42. Negative 30 plus 4y is negative 42. Add the 30, so 4y is negative 12, and divide by 4, and y is negative 3. So 3, negative 3. These are both the same line, which means that there are infinitely many solutions to the system because they intersect at every single point. So these are the same line. All right, so that means that there are infinitely many solutions, and that means that this is a dependent system. All right, so there is that example. Now, one last example, and then we will be done with this section here. So let me give you one more example of this, and this one is a little bit trickier because it has some fractions in it, so I just wanted to show you what to do when you deal with these fractions, but you still need to graph the line, even like there is no issue at all here. All right, so let's set up the coordinate system just like before. All right, so here we go. I'm drawing the coordinate system. So what a time to be alive here. So for the first line, x, y was 1/2 x plus 1, so I could pick 0. Y is 1/2 times 0 plus 1, which is 1. If x is, let's say, 1, y is 1/2 times 1 plus 1, which is 3/2. If x is 2, y is 1/2 times 2 plus 1, which is 2. So here we go. I can graph these points, 0, 1. All right, 0, 1, and 2, 2. And here we go. Here is the first line here. All right, now let's graph the second line. X and y was 1/4 x plus 3. So if x is 0, y is 1/4 times 0 plus 3, which is 3. If, let's say, x is 1, y is 1/4 times 1 plus 3. That is 10 over 4. But, and again, I did that mentally, but I knew it was going to be actually that's not 10 over 4. Sorry. 13 over 4. I was looking at the number above it. So that is why I said that you probably want to deal with whole numbers anyway, because then this will happen sometimes where you get a fraction and you're doing this mentally, and it just is a lot to do mentally, and then you have to graph is on top of that. So why don't I pick a 4, and y is 1/4 times 4 plus 3, which is 1 plus 3, 4. So one of the points is 4, 4. So we have 0, 3, and 1, 13 over 4, and 4, 4. All right, so 0, 3 is right here, and then we have 4, 4 right here, and then I can draw the line, and I think that you can see where they're intersecting, but I'll highlight it right here. It's right here, and so that will be at 8, 5, 8, 5. All right, so hopefully that all makes sense of where that is coming from. So if the problem asks for x, you would say the answer is 8. And if the problem asks for y, you would say that the answer is 5. All right, so keep that in mind as well, that you have to pay careful attention of what the question is asking. So I hope that you enjoyed this video, and what a time to be alive. Have a wonderful day, everyone.